Good morning. Good morning. You're welcome to our pharmaceutical calculations lecture, Ability 253. We'll continue from where we stopped in pharmaceutical measurements. In our last class, we started with the direct method of measurements, and we discussed measurement of liquids. You're coming. We discussed measurement of liquids. So we'll conclude. Let's say one or two things there before we move over to the measurement of solid. Remember, we said the last statement I made concerning the bore. I said that the narrower the bore of a measuring what of a graduate, the narrower the bore, the more accurate the what measurement, because it will help you to read the meniscus what accurately. And if you're able to read the meniscus accurately, that means you will be able to have an accurate what measurement. Am I communicating? To compare with when the bore is what a bit what wider, right? A bit wide. All right. So now there's something else I want to point out here. As you can see on our material, on our course material, let's assume that you want to. There's a kind of deviation, maybe deviation of about 1 plus or minus 1 millimeter, maybe out of mistake or error. As you want to read the meniscus, you have plus or minus 1 millimeter from the actual what value. It will be translated to different amounts in terms of volume when you are using a cylindrical measure as compared with when you are using a conical what measure. If you are using a cylindrical measure, just an error or a deviation of plus or minus 1 millimeter would cause about 0.5 mil error, approximately 0.5 mil error if you are using a 100 mil cylindrical what graduate. If you are using a 100 mil cylindrical graduate. But when you are using a conical measure of about 125 mil, and a deviation of plus or minus 1 millimeter in the reading of the meniscus would cause an error of about 1.8 mil. Would cause about an error of 1.8 mil. Now it is now very important that as a pharmacist or a pharmacy technician, that as you are using this measure, you should be very careful to select the appropriate measures before you do your measurements. Select the appropriate measure. At the same time, while reading the meniscus, your eyes, the lower meniscus should be at the give me marker. The lower meniscus should be at the level. Your eye should be at the level horizontal to the level of the lower meniscus. Let's assume you are working with this. Sorry, you are working with this. Are you waiting for me to tell you what to do? Whose board? My board. This is not the one I watched. Then watch this one now. No, watch this one. Leave that one there. Now, something like this now. So your eye, as you are reading the meniscus, your eye should be horizontally at this what level. Don't view from here or from here. Let your eyes be what? Horizontal, to avoid what? Error. So once, if you're able to take these precautions, you will have a what? A good what? Measurement. You have what? A good what? Measurement. Accurate what? Measurement. Accurate what? Measurement. Accurate what? Measurement. Now, so that's one thing you need to know. Then another point I want to make is that remember what I said about the weights, about the volume, the measures. What I say about remind me, what I say about measuring using a measure in terms of what you want to measure. Do you use, let's assume you want to measure 50 mil. Let's assume now you want to measure 50 mil. Do you use 20 mil? 20 mil graduates. Maybe you measure 20 pour. Measure 20 pour. Then measure 10 pour. Do you do that?
No.
So what measure do you think you should use? Please take note of this, okay? Very, very important. Now, with this, I want us to look at weight. Let me ask you. You've been weighing in the lab, right? So how do you weigh? Someone should tell me. Who normally weighs for you people? Okay, everybody weighs. Or Elizabeth, tell us how you weigh. You said everybody weighs, right? Tell us how you weigh. How you've been weighing. So what do? You do what?
You get
Plain sheet. Is that what you do in the lab? Tell me exactly what you do in the lab. Don't tell me what's on paper. You put what inside? How do you put it?
You use the spatula and get it.
Okay.
But before getting it, you first of all place you zero the electric weighing. You zero it in the middle. You now place it. If you zero, you now place your paper. Then you now take use your spatula, carry the stuff and put it on top. Then it will be reading. Once it is that exact amount, then you put a little bit overage. Then you now carry it and go and do what you
Is that the only balance you use there?
Yes.
Only. That's the only one you use there. No other balance you use there. You don't use triple beam balance. Okay. Maybe I'll make our time. We'll go there together. Yes. Get the weighing balance and look at it. I think that's what I did with this. We went there, brought out the weighing balance, and they saw they started on their own self. They started checking it safe, and so I started seeing where they wrote the sensitivity of the one they have there. They'll be late. Okay, now let's go. So this thing is stopping me. I'm not seeing my material full. In pharmaceutical measurement, we have varieties of what? Weighing balances. Please, hope you know that there's a difference between weights and balances. Weights and balances. I don't know, the one you use here, I don't think that's not what we have here. If you have class A prescription balance, there's what is called weights. maybe some are mainly metals or something like that have particular different weights. Some maybe 1 kilogram, 2 kilogram, 3 kilogram labeled. Am I communicating? That's what they use in. Unlike the electronic balance, you just press the button and the thing will be zero. Then you now take the pepper, add the powder, the ingredient you want to measure, and put. No, that one is that you need to do what? There are two pans. There are one in the left hand side and one in the what? Right hand side. That one is that if you get the pan, one of the pan is for the what? The weights. And once you put it, let's assume now you draw. I'm giving you the general principle behind class A weighing what? Balance. Okay, class A what? Weighing balance. Now once there are two pans, once you get the weights you want to measure, the weight itself, the weight you want to measure. Let's assume you want to weigh out. Let's assume you want to weigh 3 kilograms of a powder. What you do first is that make sure that the balance is clean. There's no dust. There's no particles that will alter what you're measuring, and make sure that the thing is at the zero. There is a scale that you have the pointer. The pointer is at the what? Zero. That means the two pans are what? Well balanced. True or false? Now what you now do is this: you get let's assume you want to weigh 3 kilograms. You get the weight itself, the weight that has what? 3 kilograms, or maybe you want to weigh 5 kilograms. If you may get 3 what the one has 3 kilograms plus 2 kilograms and drop, and if you drop it on the pan, on one of the pan, it do what? Go down, right? Now what you now do is this: you place the powder what you want to weigh, the pepper you want to use, or the dish you want to use to weigh the other side. Then you keep. Of course, you should know the weight of the disc alone, or the pepper as case may be. You now start adding the ingredients you want to weigh. As you are adding the ingredients, it will tighten towards that ingredient. True or false? As you add, it will be coming up. As you add, it will be coming up. The side where you are adding the ingredients will be going what? Going down. At a point, they will be at what? Equilibrium. Now, if they are at equilibrium, you look at the pointer. Once the pointer is at the zero, that means that they are at equilibrium. What it means that you have actually weighed what? 3 kilograms or 5 kilograms of the what? Ingredients. So use the weight you are putting to be able to do what? Know the exact weight of what you want to weigh. So if let's assume you are preparing something in the lab and you want to weigh out 5 kilograms or 10 kilograms, that means you have to get weight of 10 kilograms and put in the other side. True or false? Then and start adding the ingredients until they balance. And once they balance, good, you have done what? Gotten the weight you are looking for. I don't think we don't have that one here. When we bought this instrument, I didn't see that one. But I think I saw triple beam balance there. Is that lab open now? Is she there? I saw triple beam balance there. Open this in first. Okay, thank you. I saw triple beam balance there. What happened? Anyway, let's just go through this then. We go there and check it. I saw, unless I'm mistaken. Okay, now, so this is basically what happens in the what? Using what? Prescription what? Balance. We call it class A prescription balances. They are designed for the weighing of medicinal or pharmaceutical substances required in filling of prescription or in small scale what? Compounding. Note these points. For small scale what? Compounding. So some prescription balances have a weight beam and a rider, and others a dial to add up to 1 gram of weight. As required, additional external weight may be added to the right hand palm balance. So the weight is where? At the right hand what? The weight go is where? At the right hand what? Palm. Then the material to be weighed is placed on where? The left what? This is right, right? Left. Right. This is the balance. Left, right? And right. So the weight should be where? At the what? Right. And the material you want to weigh, place where? At the left what? Pan. So if you, the material to be weighed is placed at where? The left hand pan. Now, powder peppers are added to each pan before any additions, and the balance is leveled by leveling feet or balance screws. Weighing are performed, listen carefully, weighing are performed through the careful portion wise by spatula addition. You know, that's how you add. The weight may be more than the weight here if you go up, true of us. So if you go up, you reduce. You keep adjusting until they what? Balance. So this thing is done by what? Stepwise. I said that the powder are added. Okay, weighing are performed through the careful portion wise. That is by portion, using what? Spatula. Portion wise addition and removal of what? The material being weighed. With the balance being arrested, the pans are locked in place by control knob. This is I'm reading is in your material, and I'm just trying to. I want to give affirmation to what I explained. That's why it's in your material. So no need copying it as I'm just listening to it. I've already explained it. I'm just affirming what I have explained. Now, weighing are performed through the careful portion wise by spatula, addition and removal of material being weighed. With the balance being arrested, the pans are locked in place by the what? Control knob. There's a control knob used to. Had it been easier, I would have shown you, but it's not here. Maybe you can go online, check class A weighing balance. See, you can see how it operates, okay? Had it been easier, I would have shown you. Now, listen carefully, during each addition and removal of material, during each addition and removal of material, and unarrested with the lid closed for determination of balance rest point. When the unarrested pan neither ascend nor descend, the index place shows the needle is in the what? Center. They use the knob to lock up. Am I communicating? Any movement in the pan, whether they are ascending, descending, is shown in the what? The pin, the needle that is what? That should be that read on the what? Scale. So, but when it is at the 0 point, what it means that the two arms are what? Well what? Balanced. That two arms are what? Well balanced. Now, the student may wish to refer to other sources, blah blah blah. Now, listen carefully. Another point I want to make, there's a point I want to bring out here. That's what is called sensitivity requirement. Listen carefully. I want to explain something. There's what is called sensitivity requirement. It's a very, very important. Do I say quantity or whatever in weighing? In fact, if you don't know the sensitivity requirement of a weighing balance, you may have issue using that what? Weighing balance, and you may the error that is obtainable there may be such that I don't know. You know what we are dealing with is poisons, right? Yes. So you should be very, very careful about that. Now there are two things I want to point out: sensitivity requirement and the acceptable error or permissible what? Error. Sensitivity requirement and permissible error. See, the error in weighing, the error that is permissible, the maximum error that is acceptable is 5%. You should not, anything above 5% error is not what? Acceptable. So from 5% down, from 5% to what? Down. So the permissible error is what? 5%. It can be 3%, it can be 4%, it can be 2%, but it should not be above what? 5%. Now, what is this sensitivity requirement? Sensitivity requirement, listen carefully. Sensitivity requirement is defined as the load that will cause a change of one division on the index plate of the balance. Sensitivity requirement is defined as the load that will cause a change of 1 division on the index plate of the what? Balance. How do you now determine this? The abbreviation is SR, capital S and capital what? R. Capital S and what? Capital what? R. So class A prescription balance should be used in all prescription compounding procedures. I still don't know why we don't have this. Anyway, before we came in there, they have already bought this thing. Maybe it's time I make a case about that. These things are important. Even though electronic has taken over, but still, sometimes the battery can mess up. Hope you know. Yes. And you think you are ready. Without thinking you are ready. That's one problem with that thing. Yeah. All this electronic, the battery can mess you up. You think that it's working. So that's why me personally, I don't joke with, except maybe if I have what I want to weigh, the accuracy, the precision of what I want to weigh, my weighing balance cannot do it. If possible, I can if I want to, I will use my aliquot method and do it self and get my answer. But it's okay. Now listen carefully. Are we together? Yes. Now I said that class A balance should be used in all prescription compounding procedures. Now listen carefully. In class A prescription balance, they have sensitivity ratio of what? 6 milligrams or less with no load. But when with no load and with a load of what? 10 grams in each pan. Now let me explain what I mean by sensitivity requirements. Let me explain. Just listen carefully. Before that, let me read something. To avoid errors greater than 5%. To avoid errors greater than 5% when using this balance, the pharmacist should not weigh less than 120 milligrams of material. That is a 5% error in a weighing of 120 milligram. Listen carefully. Class A, they have sensitivity requirement of what? 6 milligram. Now, what it means is this: to avoid error greater than 5% when using the balance that has sensitivity requirement of 6 milligram, you should not weigh anything less than what? 120 milligram of the material. There's this formula we call the least weight, the least weighable weight. As in, least weighable weight is equal to sensitivity requirements over what? Look at this formula. This formula will explain better what we mean by sensitivity requirement and how it affects our measurements. Least weighable weight is equal to times 100%. Are we together? Hello, are we together? Yes. So if you have 6 milligram over 5% times 100%, what will it give you? 6 milligram over 5%. 120 what? Good. Now look up. If sensitivity requirement of a weighing balance is what? 6 milligram. What it means is that the least weight you can weigh using that balance is what? It's not that you cannot weigh 100 milligram. You can weigh 100 milligram, but if you weigh 100 milligram, it will introduce an error of more than what? 5%. Remember, I said that the acceptable error 5%. Must not be more than what? 5%. So that means that if you use this, and if the SR of the weighing balance you are using is 6 milligram, the SR is what? 6 milligram, and you use the weighing balance to weigh 100 milligram, the error that may occur there will be above what? 5%. So let's assume now let's assume now this is a weighing balance, and you have checked it. I will still describe how to determine the SR of a weighing balance. Let's assume now that this is a weighing balance, and you have checked the SR, and you found out that the SR is 6 milligrams, for example now, and you want to weigh, and you have a weight of you want to weigh 100 milligrams of an ingredient. Don't use the what? Weighing balance. Now, let's check the error possible when you need to weigh 100 milligrams. Watch out. The weight you want to weigh is what? 100 what? Milligrams. It's equal to what? The SR is what? 6 milligrams. Over what? The error, right? Error, right? Yeah. Times what? 100%. Find the error. Error is what? 6 milligrams times what? 100. Over what? 100. What's the answer? 6 what? 6%. 6%. I mean, now see, it's above the acceptable error. The maximum error permissible is above it. So this will not give what they are looking for. You better look for another what? Weighing what? Balance. Okay? The acceptable error is what? This is a typical council exam question, and I ask it yesterday. Council, I don't this question. When it comes to weighing, anything, when you come to any question in weighing, this you must surely see it, both in Nigeria and outside Nigeria. You must see it as a question. So far as the weighing is concerned, the acceptable error is what? 5%. It should not be more than what? 5%. So if the weighing balance is, if the weighing balance is 6 milligrams, has SR of 6 milligrams, the least weight you can weigh them to avoid error above what? 5% is what? 120 milligrams. You can weigh 150 milligrams. Perfect. True of us. You can weigh 150 milligrams. You can weigh 200 milligrams. It's okay. But apart from that, this will tell you the least you can weigh. Am I communicating? Then, of course, each weighing balance have the maximum you can weigh. Hope you know. Yes. Are you aware? You can use it to do what? Weigh. That one is not an easy. It's not that difficult to work. Determine once you get you see all those things there. True of us, good. But this will tell you the minimum. And if you want to know the scientific requirement of that weighing balance, you are good to go. So that if you are called out to talk about scientific requirement, I believe you can at least explain it what it means, right? Right? Now, ask.
Of 6 milligrams. This way, I want to know this weight and the maximum weight that you can weigh here.
No, this focus mainly on the what? The least weight you can weigh to avoid error more than what? 5%.
Okay, so the least weight is.
Huh?
The least weight is 120.
You can weigh. See the weight. Of course, hope you know. Apart from these safety requirements, each weighing balance, they have what is called their own accuracy. Hope you know. Are you aware? Accuracy. As what that means, the precision. They can weigh this thing. They can weigh. This can also weigh 100 milligrams. Hope you know. It can weigh it. Are you aware? It can weigh 100 milligrams. But the point is this: avoid the one that will make you to have a weight that will make you to have error more than what? 5%. Simple. That's what you are finding. That's what you're looking at here. Precision, accuracy, that is not the same thing with this. This is what you want to check to avoid error above what? 5%. If an error most of the error you got there will be above 5%. Error has range. Hope you know. 5%. There's maximum for a particular measurement that is what you can tolerate. There's those you cannot do what you cannot do what tolerate. So why will you please avoid anything above what? There must surely be an error, but let it not be what above what 5%. That's the watchword. So with this now, if you know the SR, you are good to go. There are some questions you will see. They'll tell you that the SR is 4 milligrams. Let's assume that the SR of a weighing balance is 4 milligrams, for example. Now, what do you think should be the least weighable, the weight you can you can use it to weigh without error, above 5%.
And wait for it.
Let's assume the SR is what? 4 milligram. What?
80.
Times what? Is what? 80 milligrams. So this now, you can weigh what? 80 milligrams. True of us? True of us? So what does it mean? As the sensitivity, the smaller the sensitivity requirements, the lower weight you can do what? You use it to do what? Weight. True of us? True of us? Now let us now go. Remember what I said about scientific. What did I define as scientific? I said the load that can do what?
Just a change of one division on the index rate of the balance.
So what do you mean that any weighing balance that has SR? Now, can we deduce something from this? Look at this. Can we deduce something from this? Look at this here. The sensitivity requirement is 6 milligram, and the weight, least weight you can use it to measure without causing error above 5% is what? 1 milligram. Now the SR has come up to 4 milligram. Then the weight you can use it to weigh without causing too much error is what? What does it tell us?
Lower the sensitivity requirements, lower the milligrams.
Yes. Deduction. That means the lower the sensitivity requirements, the more sensitive the what? The lower the sensitivity SR, the more sensitive the balance becomes. True of us? True of us? Yes. Because a balance that can weigh 80 milligram without committing much error above 5% is more sensitive than this one. True of us? True of us? That means if you want to weigh something that is below this, don't use this. Do use what? This one. Because of the what? SR. And if you go back to our definition of SR, it says that SR is what? The load that can cause what?
Cause a change.
A change. Just a drift in the what pointer, right?
Yes.
One division what? One division what?
On the index rate of balance.
Good. Now, that means small weight of 4 milligram can cause a change. True of us? But in this one, if you put 4 milligram, it will move. It will even notice that something was dropped on it. True of us? In this one now, if you put 4 milligram weight, it will even do as if something was dropped on it. True of us? It will even shift. That means it's not saying it can't detect this weight. Are you aware that there are this weighing balance you will see? Just dust particle drop on it, it will read. Just dust, you see the weight of that dust. But this one, dust will fly up and down. You will not say anything, sir. So that means that as the SR decreases, the lower the SR, the more sensitive the what? The balance. The more sensitive the what? The balance. So that's for our manual, as in this our. Okay, you have a question to ask. Okay. Yes. You know, listen carefully. See what happens here. See what happened here. Here we said, let's assume you are aware that the sensitivity requirement of the weighing balance is 6 milligram. You are aware, and you went and used it to weigh 100 milligram. The error there will be above 5%. The error there is what? 6%. So you shouldn't use it to avoid such error, because the acceptable error is what? The maximum error is what? Maximum potential error is what? 5%. So it shouldn't be above what? 5%. It can be 3, it can be 2, it can be 1, but it shouldn't be what? Above what? 5%. That's the point there. Okay? Good. Let's see if there's another point we need to make here before we. Am I completing? I don't want to go into what happened. That has passed. Now, what matters is this. You are now aware that these are things you should know. Please go and research different classes of what? Weighing balances. Different classes of weighing balances. Check the maximum weight you can use them to weigh, and check the maximum weight, the accuracy or their precision. These are two things I want you guys to check. Different classes of weighing balances. Then check their what? Accuracy or their precision. Then check their what? Maximum what? Weight you can use them to do what? Weigh. Okay? Check these two things and you are good to go. Then look at it if you can. There's this video of, maybe don't worry, when we get there, because we are going there now.
Yes, sir. Okay.
We are going to lab now. Yes, at least let's see. Maybe there's one video I used to have about triple beam balance. Maybe if I still see it in my system, I'll send to you. But if I don't see it, I'll ask for that, because I think I saw triple beam balance there. I will check it. If it's there, we'll just look at it. You see how it works. So now, once we're able to determine, check the what? SR, know the SR of the weighing balance, you are good to go. So most of this class A listing have sensitivity has SR of what? 6 milligram. Has SR of what? 6 milligram. Now, how do you remember carefully? Remember, I told you that I will just have a kind of rundown on how to determine the SR of a what? Balance. Now, we define SR as what? As the load that will cause a change of one division on the index plate of the what? Balance. So you can calculate you can calculate the SR of the weighing balance following this procedure. First of all, you should level the balance. You know what I mean by level the balance. Ensure that the pointer is at what? Is zeroed. That's what we mean by leveling. Is what? Zeroed. Now you determine level the balance, then determine the rest points. You know, there are some balance that maybe due to the fact that they are you aware that there's some balance that you will see. If you try to make it to be a zero, it can't be a zero. Maybe they are old or they have used them for a long time. But whether it is a zero or not, the most important thing is for you to know where it's resting. It may not be a zero. You can still use it to do what you want to do. But after you do what? Subtract the rest point, okay? If it's not at zero, maybe it's at 1, for example, now 1 milligram, for example, now, then you can still use it to do your weigh. After weighing, you subtract what? 1 what? Let's assume after weighing you got 6 milligram, for example, now. After weighing you got 6 milligram. And it was the rest point, it was around 1 gram, 1 milligram. What are you going to do? That means if that 6 milligram you got is not the weight, hope you know. Because that 1 milligram there contributed to that 6 milligram. So if you want to zero, you subtract that 1 milligram from where? 6 milligram, and you get 5 milligram. 5 milligram is the weight you weighed. Had it been it rests at 0 points. Yeah, if you see 5 milligram, you know it's what? 5 milligram. That's what we mean by zeroing your what? That is the first thing you should do. Very important. Don't assume that is at what? 0. The first thing you must check where it is. Don't assume that it must not be at 0. It must not. So if you know that, if you have that at the back of your mind, you will not commit such errors while what? Weighing. These are things you check. Now, so that's why we say here, you balance the what? You level the balance and do what? Level it and determine the what? Rest point. Okay? Level it and determine the rest point. What's going on here? Now, this is not, don't want to open again. Osinaka. Okay. It has opened. Now, you do what? You level the balance, determine the rest point of the balance. Now, determine the smallest weight that causes the rest point to shift one division on the what? On the what? On the what? Index. On the what? Index plate. Now, you can check, keep adjusting, keep checking the weight of part or whatever you want to do. You check the weights. Your focus is that weight that will make it to just shift. You know, it has divisions or graduations. It has divisions on the plates. Graduations like this, okay? Three of us. Now, your focus is to determine the weight that can cause the thing to just shift only one what? Division. You may put a weight, it may shift up to 5. Your intention is to know the weight that can cause what? Just one division, shift to one division. Once you're able to determine that weight that can cause it to move to just one division on the plate, that weight is the what? SR of the what? Of the what? Instrument. That is the SR of the what? Instrument. If you have seen the calibrations on the scale, like this, you may see something like this: 1, 2, 3, 4, 5. True of us? True of us? Then you have a note, you have a something like this, you have a pointer. Maybe the rest point was here. Okay? Then you now add the weight. It will shift. It may shift like this. It may shift up to 4 at a time because of the weight you added. But your attention should be in the way that will make it to just move from here to this one division. Once you move here and come here, that weight that causes you to move each one division is the what? SR of the what? Weighing balance. Once you do it, you are good to go. You have determined it, and that will help you to know the least weight you can use it to do what? Weigh without causing what? Error above what? 5% using this formula, and you are good to go. Does it make sense? Does it make sense? So that's what we mean by what? This is a very important quantity or whatever when you are talking about what? The weighing balance. Very important. So, for greater accuracy than a class A precision balance allows that if you want to get an accuracy above what class A can offer, then you start using what? Electronic what? Analytical what? Balance. Okay? If you want a greater accuracy, that's what led to this analytical balance. Remember what I said? If you listen to what I said, I said that these class A's are used for what? Small weights compounding. But if you want a greater accuracy, go down to what? Electronic and what? Analytical what? Balance. So in order of precision, what it means is that after electronic balances, you have the what? Class A what? True of us. That's the meaning. So, and they can weigh accurately as they have precision of about 0.1 milligram. Put it down. These class A's are precision of about 0.1 milligram. Because you know in your compounding, you can compound with weights of maybe 10 milligram, 2 of us, 2 milligrams, 2 of us, 5 milligram. In your exogenous compound, you can have you can weigh as small as 0.5 milligram, 1 milligram. Am I correct? So that's it. That the accuracy precision was 0.1 milligram for this class A balances. 0.1 milligram. Yes. So they can weigh accurately as small as what? 0.1 what? Milligram. 0.1 milligram. (1 milligram), and the maximum capacities range from they are not one, they are different types. Hope you know, it's a class. But the maximum capacity range from 6 grams to what? 210 grams. Maximum capacity. Maximum is a range from 60 grams to what? 210 what? Gram. Yes. The maximum weight, they can range from 60 grams to what? 210 watts. Yeah. But they can weigh, they have precision of about what? 0.1 watt. Remember what I told you? The assignment I say you should do, just do it, it will help you on these classes. What has happened. You can't be dwelling in the what? Past. I'm telling you now what you should know. Go and browse these classes. Check their precision, the accuracy, and also the maximum weight they can do what? Wait, so I have mentioned one now in this class A. I said 0.1 watt milligram precision. Then the maximum range, because it's not 1, 2, 3, there are many of them. It's a class, range from where? 60 grams to what? 200 watt, 10 grams. What's that? Because let me see what you are showing me. What you are coming is, this one is whether it's in lab. Okay, you say let's go to lab. Yeah. I'm coming now. Good. Check it up. There are different classes. Check it up. Okay? Check it up. All right. So I think I've made all the points we need to know at this level when it comes to weighing. Okay? Percentage error, go. You know, if you are talking about error, we still treat percentage error as a topic. Error, okay, you mean this error with respect to the SR?
So it's percentage error.
Don't worry. Is where? No problem. Do you have a question? Maybe we have lecture money. Come down, auntie. Be coming down. What? Yes. Yeah. No, error is always plus or minus. Yes. Anytime you see error, you may not see that plus or minus. So you may just see 5%, but it's actually what? Plus or minus 5%. That's the meaning. In fact, let's assume the accurate measurement. Let me interpret it. Let's assume the accurate measurement is. Let's assume the accurate measurement is 40 milligram. Okay, and this is accurate. This is accurate weight. Now, permissible error is plus or minus what? 5%. Find 5% of 40. 5% of 40 milligram is what? 8 milligram, right? So 8 what? Milligram. See what it means. Subtract 8 milligram from 40 milligram. 32 milligram. So add 8 milligram to 40 milligram. 48 milligram. What it means is that any weight that falls from 32 milligram to 48 milligram is what? Acceptable. I will together. That's the meaning. It's a range. That means 34, 30, 33, 35, 36, 40 is what? Acceptable. That's the meaning. But anything less than 32, 31 is not. Anything 49 above is what? 48.1 above is what? Wrong. That's the meaning. Minimum, yes. The maximum you can allow is what? 48 milligram. That's the meaning. When you see something like that, the maximum potential error, setup error is what? 5%. That means that it can enter within this range is what? Acceptable. That's the meaning. And actually, percentage error is just, percentage error is what? Is what? Desired over what? 100. 0 over 100. This is like, I don't like jumping lectures up and down. Let's take it step by step, please. Okay? But just know that, just know that we still have Monday to do our lectures. So, and the next, what's time now?
9:35.
So the next subtopic we enter is what? Aliquot method. Indirect measurement. It's after aliquot that we enter percentage error, and that's where we cap it off. So aliquot measurement. Do you want us to go and see that thing, then continue, or do we finish before we go? Huh? What do we have? What we have? Don't you see by 10:30, right? It's coming. Let us see that briefly and come back. Okay, please. We are now in the lab. Please, I want us to coordinate our lecture. We are sitting in class. Please, let's just look at this now. These ones are what? Electronics, right?
Yes, sir.
Watch. Look at this. This is electronic balance.
Okay.
This is maximum. It can weigh is what?
2,000 grams.
2,000 grams. I want to give you an assignment now. Find out what this D and E means. Find out what this D and E.
Less than or equal to.
Just go and find it out yourself. Report to me what this D and E. Just know that this has to do with what? The you can call it readability, you can call it the accuracy, or the what? The precision. Look at it, 0.1 gram. Am I communicating? Yes. But before that, I want to find out what D and E means on your own. Get back to me on that. We'll discuss it. Okay. Now look at this one. Remember I told you always check the weighing balance. You must see where they wrote those things. Without it, then you're not doing anything. It must be indicated in the balance we are using. Especially most of the balance it must be indicated there. Look at this. Can you see it now? You can snap it, check it up. What it means. The D and E in weighing balance. What in electronic balance? You can go D and E in electronic balance. You mean D and E. Small letter D, small letter E. G of my calculator. Look at this one. Look at this one. Maximum weighing is what?
0.
No, this is
510 grams.
510 grams. Maximum it can carry is what?
510 grams.
See it here. Can you see it now?
Yes. 510.
Okay. Then 0.01. The precision.
The precision or accuracy, as case may be. Look at 0.101 gram. Is it clear?
Yes, sir.
Good. Now, this one is what is the precision of this one? 0.1. 0.1 gram. This and this, which one is more sensitive?
This.
It's clear now, right?
Yeah.
This is more sensitive. Now, let's look at this one.
Sorry. Why?
They are both 0.1, 0.1.
No, this one is
0.01.
0.01. Okay.
And if you watch, this one has 0.1 gram. Can weigh more. Maximum is 2,000. Yes, why this one is 510? So this one was small waist, but this one can weigh up to 2,000 grams. Now let's look at this one. This one. Okay, this one at this same time. This one is a triple beam balance. Hold this. I say I used to have a video, but I don't know. Okay, when my system had the issue, I lost it. I will look for it again and send to you in the group. The video on how to use this, but I will explain here. Watch. Let's start on. Look at this now. The capacity. It can weigh 2,600. The capacity is 2,610 grams. Am I communicating?
Yes, sir.
What it means that what this thing can weigh This one is 2,000.
No, this is 510. This is 2,000.
But this one is 2,610. Did you notice anything here now?
Yes.
This one higher capacity than this one.
Yes.
But if you have weights less than maybe say 1,000 grams, I would suggest use this. Unless maybe the battery, you don't trust what the battery is doing. You come up with
How
this
do you
one.
even use this?
That's what this thing has spoiled. It has spoiled, okay? It has spoiled. Had it been is correct, is that the pan is here now, I would have done something, I would have shown you how to use it. But let me I'll just make do with what I have then. But it won't give you the exact thing you're looking for. Then maybe I'll if I search for that video again, I'll send it to you. You watch the video, then you appreciate it. Look at this one. This is anything you are putting here is reading here. Okay. Now do you know why it's called triple beam? 1, 2, 3. There are 3 beams. This is first beam. This first beam. Look at first beam. The first beam, the weight is 0 to what? 10 gram. 10 gram. The second beam is 0 to what? 100 gram. Then the third beam is 0 to 500 gram. If you add 500 gram, 100 gram is what? 600 gram. Plus 10.
610.
500, right? 600 and 6 what? 10 gram. Is it clear now? Good now. Let me do something now. The first thing you make is to zero it. Try as much as possible to see. This is not good. How do you mean is it good? You zero all the weights here now. All the beam was zeroed. Put this to 0. Put this to what? 0 mark. Can you see it? This should be in what? 0 mark. All things being equal. Once all these things are in 0, this thing will be here. Remember what we talk about leveling and checking the rest point. Remember that thing you are doing with class A in the class. Resting it and leveling it, then check the rest point. We have leveled it now. But let's check the rest point. Like a little bit. The rest point is not 0. This is not spoiled anyway. But it should be here.
Once you
level it, it should come up here. Because all the beams are in 0 mark. So this thing should be here. But it's not. It's a sign that it has spoiled.
Yes.
Now what happens is this. Let's assume, I just want to use to describe what you are doing. Then if I see that video again, I will send. Let's assume you want to weigh 300 gram. Let's assume you want to weigh what? 300 gram. Now see what you do. See what you do. The powder, the ingredient you want to weigh, you put the pepper. You do follow your normal procedure. Then you pour. Now you adjust this. If you adjust this, if you adjust this before you pour, if you adjust this, it will go down. First of all, you have balanced it, hope you know. Right? You have balanced it. Then you move, what you want is 300 gram. You move this one alone to 300. This one must be at 0 point. You move only the 300 gram and make it to be at this 300 point. Once you do it, it will go down. And if you go down, you then start pouring the what you want to measure. As you are pouring it, it will go up.
Stop in 0.
There's a pan here that there should be where the pepper and whatever. As you are pouring it, it will come up. The more you pour, the more it come up. The more you pour, the more it come out. It come up. If you are poured above, it will do what? Go up. It will go above the 0 mark. You start reducing. It will coming down. Your target is to keep pouring, adding, removing until this thing comes to what? 0. Once it comes to 0, and this is still at 300 grams, you have weighed
300.
Now, but if you want to weigh, let's assume you want to weigh. Let's want to weigh 300 and 400 and 400 and 408 grams. For example, now let's assume you want to weigh 408 grams. Watch. If you want to weigh 408 grams, you can place this here. 4. Then leave this one at 0. Push this one to what? 8. It will go down. You keep pouring. It will coming up until it becomes 0 here. Once it tallies with this 0, you have weighed 408. Then if you want again, I prefer this 300, but it can cause errors if you cannot handle it. So the best, just go direct and do your thing, okay? But there are some figure you want to weigh. You have to combine the 3 of them to get it. You can formulate any figure here now. Let's say 555.
500.
Or let's say 600 and let's say 600 and 608. For example, now watch. 500 will be here. 100 will be here. Then 8 will be here. You have gotten 608. It will go down. You keep pouring. As you pour, it will go up and down until it aligns with this 0. And when this is done, you have gotten the weight here is what? 608. So this is basic this thing in the what? Triple beam balance. Okay?
But this is not exam.
No. It's manual. It's not electronic. It's manual. It's not electronic. Okay, can you run electronic school?
You see more than this.
No, some schools are actually.
Hey!
Some schools are actually doing well. So I think we should go to class. Now we are done here. Let's go back to class.
Now let's check more. That's why I said don't check.
It's way embarrassed. We are here today. Don't worry. You know this one now. With time you see others. Let's go. Dispensing methods are there. Dispensing methods. You can't do the tour. A block flask. Already. Oh yeah, let's go. But that measures. No. But all we can match. I have not seen it here. Who has this phone? Take your phone. No. I'm going to thank you. Please, let's go to the class and continue our lecture, please. Hello. All right, please, let's continue before we have 7 minutes to go before your MCB lecturer comes. Please, let's settle down, please. All right, let's continue from where we stopped. We've gone to the lab. Hey, Jaffa, what are you doing? We've gone to the lab. You've seen the weight balance we have there. And this will take us to the next subtopic. Indirect method or aliquot method. 10:30 up here? One now, 10:30 up here? Okay. So, indirect method or aliquot what? Method. Now listen. You know that thing you see there? Those weight balances we made there. You've seen that some of them you've seen their accuracy, right? Their precision, right? Good. You've seen them. Now, there are situations. What I described there is direct measurement. You just get what you want to measure and do what? Because you are sure that this thing has the accuracy to weigh what you want to do what? True or false? But there are situations whereby you cannot. There are some weight. Okay, let's assume the one that has accuracy of 0. The minimum there that has accuracy of what? Let's say 0.001 gram, for example now, which is how many milligram? 100 milligram, right? 0.01 gram is how many milligram? 0.01 gram is what? How many milligram? 0.01 gram is how many milligram?
1.
Convert it to milligram. 0.01 gram is how many milligram? Convert it to milligram. Multiply by 1,000. What is the answer? 0.01 gram.
It's 10.
It's 10 milligram, right? Okay. What of 0.1 gram? 100 milligram, right? Now let's assume that you have the one that is 0.01 gram, and you want to weigh. You want to weigh something that is a weight of about 5 milligram, or even less than. What will you do? And the one you have in your compounding room or your production facility cannot do that. But you need this weight to be able to carry on with your what? Compounding. What will you do? You can weigh it, but what? Indirectly, right? Using what? Aliquot what? Method. Using what? Aliquot method of what? Weighing. So we also have it aliquot method for weighing and for what? Measuring what? Volumes. Am I communicating? We use aliquot method for what? Both volume and what? Weights. For both volume and what? Weight. So let's look at it. Remember in your first year, we did something about powder, right? In your 153, one of the first powder calculation we did at that time. I told you that when you come to FarmCalc, I will throw more light on it. And that is well explained when in aliquot method of measurement. That we will do that in your second year. So that's what we are about to do now. So let's look at it by way of introduction. When a degree of precision, listen carefully, just listen. You have this already. Just listen. By now, you know 5 times by now. Yes. So just listen and articulate what you've read and what the overview I gave a few seconds ago. Just listen. When a degree of precision, listen carefully. When a degree of precision in measurements that is beyond the capacity of the instrument at hand is required. When the degree of precision in measurements that is beyond the capacity of the what? Instrument at hand is required. Pharmacists may achieve the desired precision by calculating and measuring in terms of aliquot what? Parts. Then what is an aliquot? An aliquot is a fraction, portion, or parts that is contained an exact number of times in another. An aliquot is a fraction. Have you seen why we did fraction as a topic? Yes. Good. An aliquot is a fraction, portion, or parts that is contained an exact number of times in what? Another. We have two things now, A and B. Part of this B is contained at a particular exact number in what? B. So that is an aliquot portion. By the time I'll go deep, you understand it better. Now let's go to weighing using aliquot. Let's go to weighing using, I suppose that. In another, A and B. An aliquot between A and B. An aliquot is a portion or fraction or part that is contained of A contained in B, an exact number in the what? Another. Don't worry, it's better understood when I start the calculation, okay? That's when you see if you mix, you take a portion. If you mix two things now, weight, you take, once you mix well, proper mixing. Remember I said that mixing or blending is a rate limiting what? Step in what? Compound. Remember? Good. So if you mix well, if you take a particular portion of what you mixed, if you have A and B, let's assume you have, where did I keep them? Okay. Let's assume you have A and B. let's assume you have A and B, and A and B are ingredients in powder form. Let's assume we have A and B, and they are ingredients in powder form. We have A and B. Are we together? And they are ingredients in powder form. Maybe A is 4 milligram, and B is what? Let's say B is what? 6 milligram. Are we together? Now, and you mix two of them properly. If you mix well, and they take your average, blah 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 blah, let's assume no transference losses. You know, you put average because of losses in terms of powder transference. As you're transferring from this to weighing balance, some may get lost, some even get sticked in what you are using to mixing them. Let's assume such thing did not happen. That means the final blend, what you mixed up is what? We give you what? 10 milligram, right? 10 milligram. If you get 4 milligram of A and 6 milligram of B and mix properly and no loss, let's assume no loss. You know, you put overage because of these losses that may occur. Because if you don't put overage and there is losses, you can't get 10 milligram. You'll be getting around 8 milligram. True of us? Now, let's assume no loss and you mix properly. The final blend or mix is what? 10 milligram. Now, what it means is this. If you mix properly, if you take 5 milligram of this mixed up, if you take 5 milligram of this blend, which is half of it, inside this 5 milligram will contain 2 milligram of what? A, and 3 milligram of what? B. That's the meaning. If you mix properly and you take 5 milligram of this final blend, inside the mix, the portion you've taken will contain what? This is half of this final blend. It will contain half of this one too, and half of this one too. So it contains 2 milligram of this and what? Which is now 5 milligram. But that is if you mixed well. If you mix what? Well. So this thing I did on the board is just a summary of what aliquot is what all about. So this thing now is aliquot portion of what? This. Am I communicating? This is aliquot portion of what? This. This is aliquot portion of what? This. Are we together? And this is what we take advantage of in our what? Indirect what? Measurement. Since we cannot measure the weight directly, let's assume now that you have a weighing balance that can weigh the minimum weight it can weigh is 4 milligram. Let's assume you have a weighing balance that cannot weigh anything less than 4 milligram. Am I computing? Less than 4 milligram. Then you use to weigh A and B, but you want to weigh A 2 milligram. I want to weigh B 3 milligram, but you cannot weigh less than 4 milligram directly. But the weight you need is what? A 2 milligram, B 3 milligram. What will you do? You cannot use it. Are you aware that if you weigh this thing now, and from there you can weigh 10 milligram, right? If you mix A and B, for example, I'm not giving an example now. If you mix A and B properly and you get 10 milligram, you can weigh 10 milligram, right? From there, if you weigh out 5 milligram of that mix, inside that 5 milligram will contain what? 2 milligram of A and 3 milligram of B. Let's assume A and B are the ingredients you want to use in preparation. Having to weigh 2 milligram of A, having to weigh 3 milligram of B indirectly, but you cannot weigh it what? Directly, because you cannot weigh below what? 4 milligram. If you understood what I just said now, you have no issue with what? Aliquot measurement, whether in volume, whether in what? Weight. So with this overview now, we'll go straight to the point. We'll pick out some example now. Then we'll now solve question on it. You now cement it, and we are good to go. Now let's look at this question. Now, but as we are, by the time you start solving questions, you start seeing things like diluents, because there are some that you may not have the opportunity to do to something like this. You need a diluent that you can use to do what? Get the quantity you are looking for before you can now take the aliquot portion. So there's a question. Let's look at some questions. With questions now, we can now drive this point home. Look at this question. You can put it down, even though it's in your book, but just put it down. Look at this question. Now put it down. A torsion prescription balance. Hello? Torsion. Torsion. A torsion prescription balance has a sensitivity requirement of 6 milligram. A torsion prescription balance has a sensitivity requirement of 6 milligrams. Full stop. Explain how you would weigh 4 milligrams of atropine sulfate. Explain how you would weigh 4 milligrams of atropine sulfate with an accuracy of plus or minus 5%. Atropine, atropine, atropine sulfate. Atropine sulfate is a drug. Atropine sulfate with an accuracy of plus or minus 5% using lactose as a diluent. Using lactose plus or minus 5%. Using lactose as a diluent. The question says a diluent, yes. The question says a torsion prescription balance has a sensitivity requirement of 6 milligram. Full stop. Explain how you would weigh 4 milligrams of atropine sulfate with an accuracy of plus or minus 5% using lactose as diluent. Using lactose as diluent. Now, if you look at the question now, there's an S out there, right? Yes, sir. And there is that accuracy is the maximum permissible error there. Is there 5%? Is there, right? Plus or minus what? 5%. We use the two of them to find the least weight you can weigh with the weighing balance without committing error of above what? 5%. Remember the formula I gave you? We use that acceptable error there, even though they didn't call it error, but I'm telling you that's the error there. Maximum permissible what? Error. We use it, and we use the SR given there to find the what? The least weighable weight you can weigh using the what? Least in the sense of what will not make you to commit error of what? Above what? 5%. Now, if you use that formula I gave you, what is that weight? Have you used it? Yes. Good. So if you use that formula, it's what? 1 to 3 milligram. So that means to avoid error above what? 5%. You should not weigh anything less than what? 1 to 3 milligram. But we are told to weigh what? So how will you do it? How will you now do it? We are told to weigh, and if you try, do you know how many percent error you commit? It may be up to 50%. If you try it, so what will you now do? This is where aliquot will now do what? Come in. Chinaza, yeah, what you go? Chinaza. Thank you. So now we have calculated that one, right? And got what? Good. 120 what? Milligram. Now, let me clean the pot so we can a torsion prescription balance has SR of what? 6 milligram. Explain how you, okay, we want to weigh what? 4 milligram. Now, but the least weight you can weigh without issues, unnecessary errors, is what? 120 milligram. So we have 120 against what? 4 milligram. This is what we want to do, and this is what you can do. True of us. This is what you want to do, and this is what you can do. What? Do. So what do you now do to be able to do what? Do it. What do you now do to this one to be able to do what? Do. So the first thing you will do is to really look for a way to you look for a factor that you can multiply this with and get at least 120 milligram. Okay, the first thing is that you look for a factor that you can use to multiply this 4 milligram. At least you can get 120. You can get 150. It's okay, no problem. Now let's if you decide to use 30, so you can get 120 dot. The no problem. Now if you multiply this 4 milligram by what? 30, you have what? 120 what milligram. At least you can weigh what? 120 milligram. Now that drug you want to formulate, that active ingredient, atropine sulfate, okay, you want to formulate. See what you do. So you see, I've gotten this 120 milligram. This thing is arbitrary. I hope you know. You just multiply 30 to get 120. Okay, see, okay. You now weigh 120 milligram of this what? That atropine you want to weigh. Your target is to weigh atropine what? 4 milligram. But the least you can weigh is what? 120. Multiply. Look for a factor that if you multiply, you can get that 120 or above. I chose what? 30. I decided to peg my own at what? 120. Now this 120, you weigh that drug you want to, that ingredient you want to do what? Weigh. It's atropine sulfate, right? Then you weigh 120 milligram of what? Atropine sulfate. If you weigh 120 milligram of what? Atropine sulfate. Now, the next target, come on, sir. The next target is to add it. Remember, we are told to use lactose at what? Diluent, right? The next target is to add your lactose, right? But you don't know how much lactose to add for now. But at the end of the whole thing, you want to get, if you mix well, you want to get a blend or a mix. You want to get a mix that if you divide it, you inside it, you will still find the required amount of that 4 milligram you're looking for. Am I communicating? You can fix any amount here, but be careful not to waste what? Ingredients. Be careful not to waste what? Ingredient. I can say, okay, let me target. I can say, okay, let me target 900. For example, now, I can say, okay, let me target what? 900. Or I can say, let me target 600. You can fix this arbitrarily. You can also look at this place, look at what you're looking for, which is what? 4 milligram, and say, is there anything a number I can fix here that if I divide everything, at the end I can get 4 milligram in as a proportion of it. Now if I fix 600 milligram now. I'm starting from smaller number because I want to teach you this. I'm starting from smaller number. Let's see whether it will work. But this is not what you keep doing when you want to do it on your own. But I want to use it to do what? Show something. Let's see. Let's assume we fix what? 600 here. Now, that means what is the amount of lactose we'll add to this to get this? 480, right? God bless you. So we have what? 480 milligram of what? Lactose, right? Good. Now, if we have 480 milligram of lactose, now, if we divide, what can we use to divide? To divide, if you divide this thing by 5, will it give you 120?
Yes. Yes.
Huh?
Yes.
Are you sure?
Yes.
It will give you 120, right?
Yes. Yes.
Huh?
Yes.
Okay. Now let's go. If you divide this by 5, what will it give you? Can it work? Can it work? That's it, right?
Yes.
Can you get the whole number? That's what I mean.
Yes.
Good. Now, if you divide here by 5, will it come? 120 by 5. 24.
Yes.
24. Confirmed.
Yes.
Now, if you divide by 5, you have what? If you divide 2 by 5, right?
Yes.
You have 24. Here you have what? 96. And here you have what? 150 milligram. I want to show you something now. Perfect. You have gotten something. But watch. You can weigh 120 milligram, right? You know this is the drug, A2P sulfate. This is the what? Lactose. You mix properly and got what? 600. And you divide by 5. You divide 2 by 5. You have what? 24, 96 and what? Do you know what it means? If you mix properly and they take 120 from the mixed, from your final mix, that 120 you took will contain what? 24 milligram of what? Atropine, right? Yes. And 96 milligram of what? Lactose. Let's assume we are told to weigh 24 milligram of the what? Atropine. We are done. Hope you know. We are done. But is that what we are asked to weigh? We have to weigh what? So what do we now do? You do what? If you divide again, you cannot weigh it out. Are you seeing something now? I'm showing you the challenges you face while solving this thing. Before I now go to the solving, I'm putting out the challenges. Thank you for that. With that he said. He said you do what? Divide again. If you divide again, let's say you divide by 3 because your target is to get 4, right? You divide by what? 6, right? 6, right? Yes. You get 4 what? 4 milligram. Now, see divided by 6 is what? 32 milligram. Wonderful. You know what I talk about? By 4 it's what?
96 divided by 6 is 16. 96 divided by 3. 3. 6.
It's 6. 96 by 6 is what? 16 milligram. By wonderful. Look at it. It has contained 4 milligram, right? Remember, you are using the same weighing balance. So if you mix all these things, you got 600 milligram in the blend. Can you weigh out 20 milligram with the balance? It cannot work. Even though here you got 20 milligram will contain 4 milligram, but you cannot weigh out. So whatever you are bulking, you know what we mean by bulking. Yeah. You should arrive at what will give you what you can weigh out, at the same time contain 4 milligram inside it. This is the issue you have while solving this. So what does it mean? Tell us. It tells us that we should raise the amount of what? Direct we are adding. Does it make sense now? To be able to do what? Achieve that. So with this now, I clean this now. And now raise it. Now, Let's assume if you now raise it to if we target 1, 2 here, what will happen? If you target 1, 2 here, what do you think will happen? What do you think will happen? If you target 1 and 200 milligram here, what do you think will happen? Here become what?
1080.
What and what? What and what? 80 what? Milligram. Right? Good. Now, if you divide it by 10, what will happen? Here becomes what? 120 milligram, right? And here becomes what? 108 milligram. And here becomes what? 12 milligram. You can weigh this one out, right? Yes. But it cannot contain 4 milligram. Do you not see what you are doing now? Yeah? Yes, these are the challenges you face, so that you know how to raise your what? Bulking what? Agent, your diluent. If you stop this at 1 to 2 and divide by 10, you can get 120 milligram. Perfect, you can weigh it out, but it will contain what? 12 milligram. That means you need extra division by 3. So that to achieve that, raise this up to what? 3 times. 3 of us. 3 times more. 3 of us. 3 of us. Now let's assume we make this to be. Let's assume we make this to be 3,006. What? Let's assume here become what? 3,600 what? Here becomes what? 3,004 what? 480 milligram. Divided by 30. Divide 2 by 30. Start from here. Start from here.
4.
Start from here. 4 milligram.
29.
Here.
29.
3,480 divided by 30.
116 milligram. 3,480 divided by
30.
116.
116 what? Milligram. 36 divided by 120 milligram. How many what are you looking for?
Yes.
Huh?
Yes.
Now, if you get 120 milligram of the atropine sulfate, mix with what? Add 3,480 milligram of what? Lactose, and mix well to form a uniform system, a homogeneous mixture. Mix well. Then the total weight will give you what? 3,600 milligram. If you weigh out 120 milligram from that 3,600 milligram, that 120 milligram you weighed out will contain what? 4 milligram of the what? Atropine. You have weighed what? 4 milligram. I could have done this straight, but I will just show you. I just show you the what the challenges you face when doing this thing now. So that means if you just divide, now if you want to report your answer, you have done this calculation on your. And if you want to report the answer, simply write answer. Weigh pom. Dilute with pom to make pom and what again? And what again? Then weigh, right? Yes. Pom. You are good to go. So simply say weigh what? Because they mentioned the active ingredient and the diluent, call their name. If they, sometimes they will not mention it, they just say drug, just say the drug, okay? But this one they mention the name, just you must mention that if the name is mentioned. Weigh 120 milligram of what? Atropine what? Sulfate. Dilute with what? 340 milligram of what? Good, thank you. Lactose. To make what? 3,000 what? 600 milligram of what? Atropine sulfates and lactose mix, okay? And lactose what? Mix or blend. Anyone is okay. Mix or what? Blend. Then weigh what? 120 milligram of the atropine sulfates and lactose what? Mix. This is how to report your answer. So this is what aliquot method is all about. For weight, this is what aliquot method is all about. Where the issue lies is how to know the amount of what diluent you need. You see how we started with smaller one, and for that sometimes it will give you the correct. You cannot weigh it out. So sometimes you can weigh it out, but it cannot give you what they're looking for. So you must try the balance. You can weigh it out, and it must give you the what you are looking for. So once you weigh 120 milligram, you have weighed 4 milligram of what? Atropine sulfate. That is what aliquot method is all about. That's why I said it's what? Indirect what? Method. You have indirectly weighed what? And most times the diluent you use are also a diluent you use in the compounding. Okay, the diluent you use are always. And so you know that this is atropine you want to weigh out and use for a preparation. Hope you know. But because you cannot weigh directly, you use what? Aliquot method. This diluent lactose here should also be the same diluent you use in the tablet itself, so that it will blend well. Because you know that this one contains some amount of what? The diluent. Hope you know. Hope you know. So what you now do is this: if you now add that 120 of lactose, let's assume you are now doing the preparation now, and lactose is the diluent you are using in the preparation. If you get this 120, you know that inside this 120, lactose there is what? 116 milligram. True of us. Let's assume that the lactose you required in the compound itself is, let's assume it's 1,000 milligram. For example, let's assume that means the lactose you add will just be what? Since there's already 116 milligram in what you added, you subtract this from this, right? To know the remaining amount of lactose you need to do what? Add in the final what? Preparation. This step is just to weigh out 4 milligram of what? Atropine. That's why I say the diluent to be used has to be also the diluent you are using in the what? Compound itself, go. Because you use diluent to do it because you cannot weigh out 4 milligram using the weighing balance you have. And this 120 you weighed out contains 116 milligram of the what? Diluent. So if you now want to use it to prepare, what you are adding is 120 milligram containing atropine and the 116 milligram of what? Diluent. So if you now want to add the diluent finally for the preparation, you can't add 1,000 milligram again. You add less than 1,000 milligram because there's already 116 milligram in the what? Preparation. So just subtract and know the remaining amount of diluent to do what? To add. And if you do that way, you are good to go. You have achieved what you're looking for. That is what you call what? But let's assume that you can actually weigh 4 milligram. Diluent you add, you can easily weigh the direct, right? Then the diluent you need to add should be that 1,000 milligram that is required, because there's no diluent here again. But because you use indirect, then you have to subtract the already amount of diluent in the mixture from the one you need in the what? Preparation. Then the remaining one is what you do what? But if you go and add 1,000 milligram, it's excess. True of us. That means you are adding 1,116 milligram of what? Diluent. Any question? Any question?
For instance, this sensitivity requirement is 30 milligram.
It's 30 milligram. Then the least weight now, check it. It will be this weight should be around. Yeah, it should be around. Check what is the from 6 to 30. So multiply 120 by 30 by 5. It will give you around 6. If you divide, you know, the sensitivity requirement of what you're using is 6 milligram, right? Then you're not asking what if it's 30 milligram. 30 divided by 6 is what? 5. So multiply that 120 by 5. It will give you around 600 milligram. Do it now. You use the formula and do it and see whether you get 600 milligram. That is the importance of variation. Just multiply by, do it and see whether you get 600 milligram. Let me know. It should be 600 milligram. That is the least weight, right? Yes. Check it. It should be 600 milligram. Is it 600 milligram? Yes, because you know that 30 divided by 6 is 5. So multiply 120 by 5. You have the 600 milligram. All right. So ask. Okay.
What if after dividing with, like, what you want to use to divide, after dividing these things, you will have 120, but you have something like 8 or 24.
You cannot work.
Okay, you must divide it so
you must be able to weigh this thing out. Here must be 4. Because when you now weigh out 120, you must contain the 4 now. That's why I knew this would happen. That's why I started I was just fixing different values so you see the challenges you face. If I want to solve it, I'll just go straight to the point and do this and get my answer. But I was just adjusting it for you to know the issues you may have why solving questions like this. So 2 of them must balance. If you was there was the time we got 4 milligram here. Here was what? 20 milligram. You cannot wait 20 milligram using the weighing balance now. So what do? We keep adjusting until this and this become. You contain 4 milligram. It is a must. Then you should be able to do what? Where? If you remember, there was a time this was 1 to 2 milligram. Here it became 24 milligram. Yeah. It's not what I'm looking for. That's why we kept adjusting until 2 of them balance. They must balance. It's a must. It's a must. Is that what you wanted to ask?
No, it's not.
I ask your own.
But that's what I want.
Okay, see your own.
So for this 600 milligram, how we got is that we multiply 4 by 120, then plus 120 plus that.
We are this 600 milligram.
Like I'm here now.
Una corona class da egwu dị.
So the first we did, this is 120.
Yeah.
And you see that now we should find the fact that give us 120 and we are full.
Yeah.
So then this one that you use first. This how you got to 120 times 4. This will give us 480 plus 120 to give us 600. No.
I just see what I did. I just did 4 times this and got 120. This 120 is the amount of the ingredient you weigh out. But we started looking at the amount of diluent we need to give us a blend that will contain the amount you are looking for. We just fixed arbitrarily. We fixed 600.
So I can fix 3.
Yes, you can fix. But as you are fixing, make sure that if you divide, you can divide what you can weigh. At the same time, that same thing you can weigh should contain 4 milligram. It must contain 4 milligram. If you contain 4 milligram and you cannot weigh it, it cannot work. And if you can weigh it out and it doesn't contain 4 milligram, it cannot work. Remember, this must not be 120 milligram. Hope you know. Hope you know.
Yes.
You must not get the same answer. Hope you know.
Yes.
You must not get the same answer. But your answer you got. Look at two things you must take care of. One, that you must not get the same answer. but the whatever you get must weigh it out, and it must contain what? 4 milligrams. That basic thing. Then coming to real practical sense, in practice, if I employ you as a pharmacy technician or pharmacist to come and work in my company, and you say you are doing Aliport, hoping that this place can be 10,000 mg. Are you aware? Here can be 36,000 mg. Hope you know. This place can be 36,000 mg. Are you aware? Are you aware? This can be 36,000 mg. Let me prove it to you. Let's assume here is what? 1 to 3 milligram, right? Plus, if you have what? 36 what? 1,000 what? mg. Subtract 30,000 minus 120 is what? 35. Is it 35 or 34?
35.
Good. 35,000 what? 80 milligram, right? Yes. Good. Then to get, if you divide here by 30, it will give you what?
4. Divide by
30, it will give you 4. Divide here by 30, it will give you what? 119. 96 what? Milligram. Divide here by 30, it will give you what? 1,200 what? Milligram. Now let me explain. This person fixed his own at 3,006. See what? This person will weigh 120 milligram of atropine, weigh 3,480 milligram of what? Lactose. Mix it and got 3,006. From there, he weighed 120 that will contain 4 milligram. Oh boy. Where they weigh 120 milligram of atropine, we weigh 35,880 milligram of what? Lactose. We mix yenya senior water 1,002 contain again 4 milligram. Wonderful. 2 questions you should ask yourself is this: what is the amount of lactose needed in the main preparation of the drug? If the amount of lactose needed in the main preparation is less than 1,002, you have messed up everything. Hope you know. True of us? True of us? Good. But if it is less than 1,002, what you add. Remember, you are not weighing that atropine alone. Hope you know. By the time you weigh at 120 milligram, inside it will be 4 milligram of atropine and the lactose 116 milligram. And if you need if in the entire preparation you need 600 milligram of lactose in the entire preparation, for example, now, that means lactose you will add again to complete it with other ingredients. It's just subtract this from what? 600 and you add the remaining one. True of us? But if you need only 600 milligram of lactose in your preparation and you go and do your own like this, and if you get 1,002, inside of 1,002 you have 4 milligram of what? Atropine. The remaining 1,996 is lactose, and what you need is 600 milligram of lactose. You have messed up the whole thing now. It cannot work. True of us? And if you say let me divide it, it can't work, because you will not get 4 milligram of atropine again. True of us? That is the first error Obo will commit. Me also is on Ojogo suspension. Now, another issue again the person may have is that, let's assume is lactose you need is above 1,002 or above 1,002. Fine, it's okay. Anyway, that one is not really an error, because all you need to do just add small lactose again to make it up. True of us? So this is the basic thing you need to do. What? Check out before you know where you are pegging your own. Find out the amount of that diluent you need in the preparation. Does it make sense? That will tell you where to peg the maximum you should go in pegging your own. Am I communicating? Then another error. Are you aware that this thing can also be? Are you also aware that this atropine, if you like, you can fix atropine at 1,000 mg, 1,002 mg? Are you aware? Yeah, if you like, you can multiply by 300 and get 1,200 milligram of what? Atropine. From there, you take small and waste it, and then when you do what? You pour it away. I'll take it from your what? From your what? Sorry.
So this way.
Because you should be wise and don't waste my what? My what? My atropine. Because in this case, that you are wasting what? Atropine. So as I am multiplying, be careful not to waste what? At least with this. Watch out now. You use 120 milligram of atropine. Do you know how many atropine that got wasted? 116 milligram wasted. I hope you know. Yes. Are you aware? It's wasted now, two of us. Because what you need is what? 4 milligram. 116 is what? Wasted. Then you go and multiply by 300 and got to 1,200 milligram. And these drugs are very expensive. They are very, very what? Expensive. Then you go and get 1,200. After you take 4 milligram and waste 1,900 and something. Don't worry. I don't want to do what? Calculate it. Maybe it may be a salary for like 1 year. No, I'm just telling you the importance of what? Doing your calculations what? Properly. So you can use any number. What matters is this: 3 things. Don't waste ingredients. Then make sure that lactose you are adding doesn't exceed the amount you need. These are the precautions you take. Put it down. It depends on the formula of your production now. Formula you look at the formula. The formula you are using, in your practical, don't they give you formula? Look at the formula of the diluent you need, formula of lactose. Look at the amount of lactose you need in the formula. Two of us. That will tell you what amount to use. If the amount you have there is 600 milligram, and you go and bulk it to be up to 1,200, it cannot work. Two of us. So the precaution is that number 1, ensure that the lactose you are using does not exceed. Ensure that the lactose you are using in your aliquot method does not exceed the amount in the formula. Number 1. Number 2, ensure that you don't waste the active what? Ingredients. That the lactose you are using, the amount of lactose you use in aliquot measurement does not exceed the amount of lactose needed in the final what? In the main what? In the main what? Compounding of the what you want to produce. True of us, these are things you check. Of course, I've already told you that lactose, the diluent you use, should also be the diluent you need in your preparation. True of us, you cannot say that you want to use the diluent, you go and use lactose. Whereas in the preparation, you don't need lactose in the formula. Would it work? You are adding your own ingredients. True of us. True of us. You are adding your own ingredients that you're not in the what? Formula. True of us. So these are the things, precautions you will take. In our next class, we look at what? Aliquot measurement of what? You use aliquot measurement for what? Volumes. Okay? All right.
Let's solve another example.
You know they need 4 mg. Like 150 is remaining.
Yes. It's a waste now. It's a waste now. Unless sometimes depending on anyway, I just want to. If it's 1 tablet you are producing, it's a waste. But you do your calculation where no more tablet you are producing. That's also depend on normal tablet. This is just for. Hope you know that. They hope you know that this is just for 1 tablet. Hope you know. Yes. Please, she asked a question. She asked, why can't you use the remaining 1 here for other tablets? I say it's okay, but what you are doing is for just 1 tablet. True of us. But if you are doing for more than main tablet, you do your calculation well, so you don't waste your what? Ingredient.
So you make that 1 tablet contain 4 milligrams.
No, Bokia. There are other ingredients there you add. This is just for to be this lactose you added there is just to help you to be able to weigh the what? Atropine. That's why I say, because this contains the lactose. As you are adding the lactose in the final preparation, ensure you subtract the one that's already there from the amount you need. If not, we are adding excess lactose.
That means this amount is required.
Yes. I think we stop here because in our next class, you can ask, if you go through the material, any question in our next class, you can ask those questions. Then, as she said, we'll solve one more question or so before we enter volume. In the absence of any other question, I think we'll stop here. Even if you have questions, I will not answer because the lecturer is there. So we'll continue in our next class. Thank you very much. God bless you.